Okay. So what is atmospheric pressure? What is atmospheric pressure? Let's say the weight of the column of air on this cross section of land is the atmospheric pressure here. Okay? So air has volume and air has weight. So it will exert some pressure. Okay? So the pressure exerted, or this weight of this column of air that it is putting on the ground, is the atmospheric pressure. So how is pressure measured? Pressure is measured in millibars, inches of mercury. ठीक है? Hectopascals. ठीक है? Yeah, we can call it pascals too, no worries. So basically what happens is, let's say this is the ground surface, and let's say we are taking a cross section of area. So these molecules of air, the weight that it is exerting over this surface is the pressure, or the atmospheric pressure. So generally 290.92 inches of mercury is a standard pressure near mean sea level, or we can call it 1013.25 hectopascals or 1013.25 millibars. Alright, so this is what is atmospheric pressure. Now, line joining places of equal pressure is called isobars. Okay, so let's say here the pressure is 1016, here it is 1014, and here it is 1012. Okay, 1012, 1012, 1012, 1012, 14, like this, and 1016 like this. Okay, so this isobar will form pattern of 1014. This isobar will be pattern of 1012, and this line joining places of equal pressure is called isobar. So this line is 1016. All right. So you can find it as open line, and in a lot of areas you will find it as closed lines. So these are closed lines of isobars. Generally because of the Coriolis force, which is, because of rotation of the earth and because of Coriolis force, there is this turning effect, vorticity. And because of vorticity, generally in the weather charts you will find it to be a closed system. Okay. So it's a closed system, and let's say if here it is 1012, 1013, 1014. So what is happening? Here in the center it is low pressure, and outside it is getting high. So the center is what denotes that this system is a low pressure or a high pressure. So this is a low pressure system. Okay. Now let's do it the opposite way. Let's make it 1016, 1014, and 1012. So this makes it as high pressure system because the center isobar is at the highest pressure. Alright. So now let's understand the characteristics of a high pressure system and the characteristic of a low pressure system. So in the North Pole, we're talking about North Pole. What is happening in the North Pole? Let's see. There is this isobar. and pressure is increasing as you are going outside. So this is called a high pressure system. Sorry, the pressure is decreasing as you are going out. Okay. So what happens? Air always flows from high pressure to low pressure. Okay, so let's say here the pressure is 1016, and then here the pressure is 1012, 1012, 1012, 1012. Okay. So air will flow from high pressure to low pressure. So what is the characteristic of this high pressure? In a high pressure system in northern hemisphere, the air will flow clockwise. How it will flow? Clockwise. Okay. The other name of a high pressure system is anticyclone. Write this down. Elongated area of high pressure is called ridge. Now, a series of high pressure together is called ridge. In a high pressure system, the air descends. In a high pressure system, air descends. Descending air out of a high pressure system. Let's say the air first comes out and then goes down. Okay. Outward flow. Outward flow. And stable air. Air will be stable. Stable meaning the vertical motion will be very less and there will be not be lot of turbulence around this. Air will be smooth and calm. Okay, so these are the characteristics of a high pressure system in the northern hemisphere. Okay, all right. Now let's talk about low pressure system. This is 1000 hectopascals, 1000 hectopascals, and this is 996 hectopascals. In the center we have low pressure, so this is called a low pressure system. So what is the characteristic of a low pressure system? Let's see.
It is anti-clockwise.
Yes. Anti-clockwise flow of air. It is also called cyclonic flow. Third,
It is
it is called elongated area of low pressure is called trough. Air is flowing inwards, so inward flow. So it flows inwards, and after inwards it accumulates at one place. After accumulating at one place, it will start rising. Okay, so rising air. And unstable. Unstable. So now this system, when it is very prominent and very significant, so this low pressure system, when it forms over the oceans, then generally there is a formation of a cyclone. Okay? So for a cyclone to form, so this can be a normal low pressure system, this can be a weak low pressure system, there can be a low pressure system over the land. Okay? But cyclone is a very prominent low pressure system which has high scale winds, which has lot of moisture. Okay? So there will be cumulonimbus cloud formation, and this cloud formation will be there, and there will be a series or an entire, you can say the entire school of thunderstorm that is formed by this, and this big low pressure system that is formed, and this big low pressure system will make a cyclone, and because of cyclone you will have like a very bad weather condition. Yeah. So there are different parts of the cyclone, but before discussing the different parts of the cyclone, let's see what are the different conditions required for the cyclone to form. Okay. So what are the conditions required? There should be a lot of moisture. Okay. Let's see this. Can I write this down? 1. Warm sea. Okay. Now what do you understand by warm sea? Let's say approximately we can say the temperature over the ocean or the sea is at least 27 degrees centigrade. Okay. So if the sea will be warm, so what will happen? There will be, because it is warm, so air is evaporating, and there is a lot of moisture. There is a lot of moisture and a lot of vertical movement upstairs, so rising air. Alright, that's one factor. Second factor is there should be kind of a rotatory motion. So rotatory motion will happen. Why? Because of the presence of the Coriolis force. So normally what will happen? Earth is moving from west to east. There will be rotation of the earth, and this will cause vorticity. There is a low level wind shear. You know what is wind shear?
Flow of air.
Yes. So here, because of Coriolis force, there is vorticity. And what is happening? The wind is changing its direction. There should be some kind of a wind shear. Then only it will propel. Because the wind is changing direction, if there is a steady flow, then this cyclonic motion won't happen. Because there is wind shear, so it will help to trigger that cyclonic motion. Alright? Because we are over the water, so high humidity has to be there. There should be a low pressure system existing already. Okay, there should be a low pressure system that is already existing, maybe a weak low pressure system, so it will build on that low pressure system. A weak low pressure system will turn into a very strong low pressure system. Okay. At higher altitudes also there should be some kind of a winds. Okay. So there should be a strong wind at the high altitudes, which will require to pump the rising air. So what is happening? This air is rising, and this air is rising, and after rising it should not subside. After rising there should be a strong airflow upstairs, so that this wind is pulled up, and further this air is rising. Because this air will be displaced, then only you can have new air going up, right? So this convection that is happening, it is propelled by the strong winds, that is not very strong but significantly strong wind. So which will pump this thing and it will keep on happening. So now what is happening? Okay. is rising up, wind is flowing, and vortex it is up. So this will keep happening, and eventually it will make candy floss. And once the candy floss is made, it is a big low pressure system. Right, you see how candy floss is happening? Vorticity. That's it. So this is basically how a cyclone forms, right? And now we can see like what are the different types of cyclone and what are the parts of a cyclone. Okay. So okay. So this is one diagram that you will see. Second diagram you will see is like a eye formation, and then there will be cyclone formation. Okay, this is what you will see, right? So this center is the eye. This first layer is the eyeball, you can say. This you can say, or this you can say. This is the eyeball. Here you can see this is the eye. And this first wall is the eyeball. So एकदम center the eye is थोड़ा सा stable area, comparatively stable, but eyeball is the area which is the most dangerous area, most unstable area. Okay. So eye we can say is relatively calm, and the wind is approximately 20 to 40 miles. Okay, and the eyeball is where the wind is maximum. It can go to whatever speeds you can imagine. And then eye is there, eyeball is there, and then उसके बाहर में accordingly it will depend on what intensity of cyclone it is. So यहाँ पे it is maximum, उसके बाद it will obviously decrease as you go outside, and here also it will decrease the wind speed. Okay, there are different names given to the cyclones. Can you name a few?
Tropical, hurricane,
Okay. Hurricanes, cyclone, typhoons, very good. So, over Indian Ocean it is called tropical cyclones. Over China Sea it is called typhoons. Caribbean Sea it is called hurricanes. In USA it is called tornadoes. Yeah. And in North Australia it is called willy willies. And if there is a cyclone just exactly over water, and it is touching the water, and if this water is also being soaked in, just not the air. So if water is involved, then it is called water spout. Okay, so that is cyclone in water, you can say. Cyclone in water is about water spout. But if it is over water and it is only made of vapors and then it is coming, then it is cyclone. Okay, so this is an overview of cyclones. Alright, and yes, once we study like tropical systems, we'll be studying much more in details. This is just overview. Okay, so what it is a low pressure system. It has been nourished. Conditions are such that this low pressure system was nourished and it is made very mammoth. When it is huge and mammoth, then it brings a lot of destruction. The wind speed increases, the moisture content is a lot, and so there will be a lot of rain, a lot of thunderstorm, and a lot of rainfall, a lot of winds. So that is what it is.